Hello, this is Mr. Collier, and today we're going to review some exponential and polynomial functions. Alright, in this question here, we're given the graph and we're given the form of the equation. We need to find the constants k and c. So usually the easiest thing to do is to find the c value, because the c value is equal to the axis of symmetry. Alright, so if we take a look at the function here, we can see the axis of symmetry is right here. The axis of symmetry is y equals -3. So we have right away that y equals k times 2 to the power of x minus 3. Okay, so we have c equals -3. And to find the k value, we need to substitute a point into the equation and solve for k. And usually the easiest point to substitute is the y-intercept. So in this case, we have 0, 2 as a point on the function. We can substitute that in. We get the following. And that gives us 2 equals, now that's just 1, so it's just 2 equals k minus 3. We add 3 to both sides here, we get k equals 5. Alright, so we have k equals 5. Now our equation is y equals 5 times 2 to the power of x minus 3. So when we answer part B, find the value of x when y equals 60. So we're solving this, which you could figure out with some logs, or we can use our graphing calculator to figure it out. So we're going to use the graphing calculator and type in the function first of all. So the function is 5 times 2 to the power of x minus 3. Alright, I'm going to go to, well actually I want my y values to go up to 60 at least. So I'm going to change my window to go up to maybe 65, a little bit more than 60. And x values, I don't know how high I need to go for the x values. Exponential functions grow pretty quickly, so I probably don't need to go up to 30. Maybe I'll try 15. So graph that. Oops, I forgot one thing. In order to solve this equation, I have graphed this already. And also now I need to graph this equation, which is going to be y equals 60. So I'm going to graph y equals 60, and that will solve the intersection of y equals 60 and y equals 5 times 2 to the power of x minus 3. So let me graph that and see, oh, there we go. We see the intersection right there. So I go to second function trace. I go to intersect, which is number 5 here. And I just press enter, enter, and try to go a little bit closer, I guess, to the point of intersection. And there we go. So we get, this is our intersection. So it asks us for find the value of x. So we're just interested in the x in this question. So we can say by finding point of intersection using GDC, x equals 3.66 rounded to the nearest 3 significant figures. Okay, you might want to include a sketch too. I want to include a sketch showing this point. This point is 3.66, comma 60. Okay, next question. We've got these two functions, f of x and g of x. We're going to graph them on this domain and range, so it tells you your window that you're going to use. So I'll go to graph these. This is x squared. And the second function is 2 divided by x. And your window, both your x and y are going from -4 to 4. Oops, I made a big mistake there. X min is -4, X max is +4. Leave these at 1. Y min is -4, Y max is +4. There we go. Okay, graph that, and we should see a point of intersection, and there's the point of intersection right there. Alright, y equals 2 out of x is this hyperbola there, and this is the parabola y equals x squared. And we're going to find, well, let's see what the next question says. Write down the asymptotes of g of x equals 2 over x. Okay, so that's just this one right here. And the asymptotes are x equals 0 and y equals 0. So actually, let me get this whole graph and put it over here. Alright, so the asymptotes of the function g of x are x equals 0 and y equals 0, as you can see here. That's y equals 0. This is x equals 0. Okay, so those are the asymptotes. Now hence solve the equation f of x equals g of x. So we're solving the equation x squared equals 2 out of x. Now you can solve this algebraically, or you can solve it with the graphing calculator. Let's do both. Okay, sometimes you can't solve algebraically. You need the graphing calculator, so let's practice that. Second function trace, intersect is number 5. And first curve, second curve, I just press enter, think. My cursor. Okay, I want the second curve, so enter, okay. Go close to the point of intersection. Press enter, and there is our point of intersection. Okay, so I'm going to paste that in here. Alright. So you could say the point of intersection by GDC is 1.26, comma 1.59. Okay, and here it is right there. You can see that and label it 1.26, comma 1.59. So that means that x equals 1.26 in this function here, f of x equals g of x. That's the point at which those two functions meet. Okay, to solve algebraically, you could do x squared equals 2 out of x, and then multiply both sides by x. You get x cubed equals 2, and x equals cube root of 2. So let's just check that out on the calculator. I can go to quit this, and go to math. Cube root is number 4 of 2. So you get 1.26, which is the same as we got before. So x is approximately 1.26. Okay, in the next example, this is several steps. So we're going to do this one step at a time. Write down an expression for the volume of the box. So in this case, we've got the dimensions of the box are 2x, x, and h. So the volume equals 2x times h, which equals 2x squared h. Write an expression for the height in terms of x. So to do that, actually, we could use the volume. That should be cubic units. The volume is 200. So I can do 200 equals 2x squared h. So if I divide by 2, I get this. And to solve for h, I divide by x squared. We get h equals 100 out of x squared. So that is h in terms of x. Write down an expression for the surface area of the box in terms of x and h. So surface area, you've got a cuboid here. There's 6 faces altogether. You've got hx here, but there's 2 of them. Right? So your surface area is going to be 2xh plus, now this face right here is going to be, well, this is 2x and this is h, so this is going to be 2xh, but there's one in the front and one in the back, so altogether that's 4xh. And this thing on the top here, well, this is x and this is 2x, so this face is x times 2x, which is 2x squared. There's one on the top and the bottom, so it's 4x squared. Okay, now we want this whole surface area, oh, in terms of x and h, yes, okay, so that's what we've done. Now we're going to show that the expression for the surface area can be written like this, which is just in terms of x. So we can take our expression from here and just substitute in our value of h. h is 100 out of x squared, so we have 2x times 100 out of x squared plus 4x times 100 out of x squared plus 4x squared. Okay, so here we get 2x times 100, that's going to give you 200, and x to the power of 1 divided by x to the power of 2 gives us just x. And over here we're going to have 400 out of x, and here we have 4x squared, which equals 4x squared, and add these two together we get 600 out of x, which is what was required in the question. Okay, we're going to sketch the graph from 0 to 15, so let's use the GDC to help us with that. Okay, we're going to type in 4x squared plus 600 divided by x. Alright, and the window, we need to go from 0 to 15. Now the y values shouldn't be negative. We're not interested in negative values. The y values are going to be surface area. I suspect maybe up to 1,000, since we got this 600 in the equation. It might be up to 1,000. Let's try 1,000. Oops, that's 10,000. I don't know if we need that big. So I'll try 1,000, and let's see if we can graph and see the whole function. It looks like we can. It looks pretty good. So we went up to 1,000. Let's actually take a copy of that. Alright, so let's sketch the graph here. You want to maybe label how far we went here. This is 15. This is 1,000. And here's what your graph looks like, kind of like that. Okay, so that is A. Call it A of x maybe. Okay, find the value of x for which the box has a minimum. So your minimum point is going to be down there. And we can do that with the GDC. Second function, trace, minimum is number 3. And let's go to left bound. Okay, and press enter on right bound. Enter, guess right on there. Okay. So we've got, let me copy that. Alright. So find the value of x for which the box is a minimum. Well, the point of intersection is, or the minimum point is 4.22. 213. Okay, so the value of x that makes it a minimum is going to be x equals 4.22, and the minimum surface area of the box is the y coordinate there, which is 213. Now, we were given units in the question. These are centimeters, so let me say minimum surface area is 213 square centimeters, and this value of x is 4.22 centimeters.